So we have two practice problems here. So we're going to do the first one together. It says a sample of a gas has a volume of 5.0 liters when at a temperature of 37 degrees Celsius and a pressure of 220 atm. Find the number of moles of gas. Well, we have the volume, which is 5.0 liters. We have the temperature at 37 degrees Celsius and a pressure of 220 atm. Now this problem is asking us to find the moles of the gas. So the equation that we're going to be using for this is our ideal gas law equation, which is PV equals nRT. So pressure is given in the problem, so we know that pressure equals the 220 atm. We're given our volume, which is 5.0 liters. We're not given our N. Our N, remember, is moles, so we know N is our question mark. Now remember, R is our gas constant, and R is always going to equal 0.0821. Then we get our temperature, which is given to us in Celsius. But remember, we don't want Celsius for our temperature, so all you're going to do is you're going to add 273. So when you take 37 plus 273, you get 310 Kelvin. So those are all our variables. So all you're going to do is you're going to plug it in to the equation. So we got our 220 for our pressure, timesing our 5.0, which is our volume. We don't know our N, so we're just going to rewrite N. We know our R. And we know our temperature. So now we need to figure out how we get N. And to do that, we got to divide this to both sides. So we have to take the 0.0821 times the 310. We got to divide that to both sides. So that means this cancels because you're dividing itself. You get 1. So all you're going to do is you're going to multiply, and then divide. So you would get, let me calculate that real fast. So our N that we get is 43, and N is moles, so your unit is going to be moles. That is all you do. Make sure you have a number and unit. Don't leave your numbers naked. Okay? So let's go ahead and move on to our next problem. Now, our next problem says 1.6 moles of methane, CH4, has a pressure of 4.44 atmospheres at 250 degrees Celsius. Find the volume occupied by the gas. So we are given moles, the 1.6 moles. We're given pressure, 4.44. And we're given temperature. And our problem is asking us to find our volume. Again, the equation we're going to be using again always is going to be our ideal. So that's PV equals nRT. And we'll go ahead and start listing out our variables like we did in the last example. So P, our pressure, we know is 4.44 atm. That's just from the problem. Our volume, we want to find that, so we're going to do a question mark. We don't know our volume yet. Our N is given in the problem, which is 1.6 moles. And our R, remember, is our gas constant, so R is always going to equal 0.0821. Then we get our temperature, which is 250 degrees Celsius. But remember, we never want to use Celsius in these calculations, so we're just going to add 273. So when you do 250 plus 273, you get 523 Kelvin. So now we got all our variables listed out, so we're just going to go ahead and plug it in the equation. So our pressure, we said, was 4.44. Our volume, we don't know, so we're just going to rewrite V, equals our N, which is our 1.6. Our R, oh, I forgot to write that 1 at the end. Our R is that 0.0821. And our temperature is the 523. We got to get V, volume by itself, so we're just going to divide 4.44 to both sides. Just basic algebra. So that cancels. So V would equal multiplying all these numbers divided by a 4.44. So we get 1 point. So let's see how that equals. And that will equal, so our volume equals 15 liters. Right, volume always going to have a unit of liters. There you go. That is all you do.